further. So the types of these opioid receptors, which reduce pain, which help us less suffer, they are mu opioid receptors, delta opioid receptors, and kappa opioid receptors. So what we can see here, in fact, the main function of these um, opioid receptors, mu, delta, and kappa receptors, doesn't matter, is analgesia. Yes, analgesia and analgesia. You see? So it means that our opioid receptors mainly effect as reducing pain. Reducing pain and reducing pain, guys. This is the most important thing which opioid receptors do. So once again, when the impulse of the stimuli goes to the brain to send us the signal of pain, at the same time, in that same neuron, the opioid receptors are activated, mu, delta, and kappa receptors are activated by activation of these receptors, the impulse becomes slower and weaker, and we have less pain sensation. Okay? Well, so now let's see what other effects do they have except analgesia. We can see here that mu receptors, they have many different effects, and delta kappa only several effects. Okay, in mu receptors, well, firstly, localization. Localization, they are located in antennoceptive system. Logically, all these receptors here in antennoceptive and delta and kappa also. Antennoceptive system, that means the neurons which give us pain, but they have opposite function. Okay, cortex. Cortex what? Brain cortex. What will be the effect of this? Being located in the antennoceptive system, they give analgesia, as we already understand. Analgesia, reduce pain, euphoria, and addiction. We will talk about that later. How does that happen? Why we have euphoria? Why we have addiction to this stimulation of this receptor? Then cortex, brain cortex. What happens? Suppression of the cortex, drowsiness, of course, and indirectly bradycardia and meiosis. How? How? I will explain. In the brain, we have cortex, and we have some subcortical structures, in which we have some, как называется, черепно-мозговые нервы. Черепно-мозговые нервы, cranial brain nerves, I guess. So they are subcortical structures, and what we know, when the cortex is active, it inhibits the subcortical structures. Inhibits, yes? Inhibition. This is the function of subcortical structures. But when we have suppression of cortex, so it doesn't work. So we don't have inhibition. And it means that these subcortical structures, they can be activated because there is no inhibition. And when subcortical structures are activated, the centers of these cranial brain nerves can be also activated. So, for example, bradycardia. This is activation of nervus vagus. Nervus vagus. Because this is a subcortical structure which can be stimulated because we have inhibition of cortex. And meiosis, this is due to stimulation of another nerve, nervus oculomotorus. Nervus oculomotorus. Nervus oculomotorus. So guys, this is also one more center of the cranial brain nerve, the cranial cerebral nerves. I don't really know, sorry with that English definition. Черепно-мозговых нервов. Okay, next, respiratory center we're looking at. And in respiratory center, when we stimulate nerve receptors, we have respiratory depression. So guys, Pay attention, a person can die because of respiration arrest. Cough center, of course, inhibition of cough center. That's why we have some drugs, new receptor agonists, which stimulate opioid receptors in the cough center, by which effectively inhibit cough. And we use that to stop cough. Yes. Vomiting center. Vomiting center is interesting. It can be predominantly stimulated. Yes, unlike the cough center and respiratory center, the vomiting center will be stimulated. Actually, why? Because of stimulation of the trigger zone. Trigger zone of vomiting center. It is not that direct stimulation. More trigger zone of vomiting center will be stimulated. When we are talking about hypothalamus, we have the effect suppression of the center of thermoregulation. So if this happens, of course, the temperature of the body of the patient will be reduced if he uses the drugs which will affect on this mu receptors. Okay, then in pituitary gland, we have the effect of weakening of the production of gonadotropins and increased production of prolactin and antidiuretic hormone, ADH, antidiuretic hormone. Okay. In gastrointestinal tract, so you see almost the one which is not central. Yes, all these effects were in the CNS, and one effect peripheral in gastrointestinal tract. We have reduction of peristalsis, spasm of sphincters, and weakening of secretion of glands. So you see the GIT, the actually work of GIT stops. So we have, if we have diarrhea, it will stop. Constipation, actually, it will cause. Okay, delta receptors, excitant and nociceptors, are also located in the respiratory center. And if they are stimulated, they also cause respiratory depression, which we, if you remember, also had in mu receptors. And talking about kappa receptors, they have one very, very special thing. They can cause by effect on kappa receptors, they can have dysphoria. Dysphoria, guys. Unlike other receptors, here in mu receptors, we have euphoria. And in kappa receptors, if you stimulate only them, we will have dysphoria. Dysphoria, it means bad mood, everything becomes unpleasant, and so on, like a very, very bad mood. And in euphoria, opposite situation, very good mood, being cheerful, being happy, and so on. So in dysphoria, we have total unhappiness. Total unhappiness. Okay, please make a screenshot of this, because this is a really important information for the class. Okay, next. Sorry, why?